Okay, now in this video I want to talk to you a little bit about how to find percentiles or percentile values for a variable. And percentiles are essentially they're values for a variable. It's a value of x, some variable, where there is a specific percentage of cases or observations with smaller values. Okay, with smaller values. So um, if you're looking for, by way of example, let's say we had the 20th percentile. Okay, the 20th percentile. We might say that this value of x would be value of x where 20% of observations were less. 20% of the cases are smaller or have a smaller value. Okay, and so this is really good for comparing values. If you want to know where a particular observation or what particular value of x falls relative to the rest of the distribution. So you might be interested in the 50th percentile. What is the value of x right in the middle of our sample of observations? We might want to know what's the 80th percentile or the 90th percentile. In other words, at what value of x do we find that 80 or 90% of the observations have smaller values? And we can do this fairly easily using cumulative percentages. Cumulative percentages, which you saw how to calculate in a previous video. So we'll go ahead here and we'll work with this example data set that we have, where we have a sample of 20 observations or 20 people, and let's say we've collected data on their ages. These might be college students, age 18 to 22, and we'll go ahead and begin by taking this frequency distribution table, and we'll calculate a column of percentages. So all we're going to do is calculate the percentage of observations that fall in each one of these age categories. Okay, so there's 3 observations out of 20 for 18-year-olds. That's 15%. 4 out of 20 for 19-year-olds is 20%. 6 divided by 20 and then multiplied by 100 again, this is going to be 30%. And then 5 out of 20 is 25%. And 2 out of 20 is 10%. And if you add these up, you'll get a total of 100%. Okay. We've also seen in a previous video how to calculate these percentages and create this column. So if you need to review, you can go back and look at that. Now we'll come forward here and we'll go ahead and calculate a cumulative. Now that we have our percentages, we'll calculate a cumulative percentage category. And the cumulative percentages can be calculated in this way. We'll begin with our first category with the lowest value for age, which is 18, and we'll move our percentage over here. This is 15. And now we'll just create this running total column of all the percentages. So we'll add 20 to 15 to get 35. We'll add 30 to 35 to get 65. Then we'll add 25 to 65 to get 90. And we'll add 10 to 90 to get 100. Okay, so now we've got our cumulative percentage column. And you'll recall that cumulative percentages refer to the percentage of the total sample, that has a particular value for the variable or less. So in other words, our cumulative percentage for 19-year-olds, age 19 in our sample, is 35%. And what that means is that 35% of our sample is either age 19 or less. Okay, either 18 or 19. And you can see that that's true where we have 15% for 18-year-olds and 20% for 19-year-olds. Well, how is this going to help us to find percentiles or to determine the value of age in our sample at specific percentiles? Well, we can do it. We can use the cumulative percentile column to find the specific value of x, or age. We need to find the value of age for specific percentages. So let's say that we're looking for the 40th percentile. Okay, what we want to do then is we want to find the value of the cumulative percentage column, the first value, moving from the lowest category on up to the highest category for age, we want to find the first cumulative percentage row that is greater than the 40th percentile. Okay, so the 15th percentile, or 15th percentage, cumulative percent here, is not greater than the 40th percentile. 35% is not greater than the 40th percentile. But aha, this next category, the 65 cumulative percentage, is greater than the 40th percentile. And in fact, what we can say is that we know that in this particular category ranges from, let's say, the 36th percentile to the 65th percentile. Okay? So 20-year-olds, these 6 20-year-olds cover the 36th to the 65th percentile. They represent that proportion, or that percentage, of the total sample. And so the 40th percentile falls in between those two, and we'd say that the 40th percentile for age in this sample is 20. Okay, we're looking for the value of the variable that happens to correspond to that age group, or that corresponds to that percentile. So let's look for another one. We'll say we have 66th percentile, and we start at the lowest category. 15 is smaller than 66, 35 is smaller than 66, 65 is just smaller than 66th percentile, but it still is. And then we find, aha, here's 90, and the cumulative percentage of 90 actually covers the 66th percentile to the 90th percentile. And so we would say clearly our 66th percentile for this distribution will fall into this particular age category, which is 21. So the 66th percentile would be 21-year-olds. And we'll go ahead and do one last one here, where we look for let's say the 95th percentile. And again, we already know that this fourth category goes up to the 90th percentile. And so the last category must cover the 91st to the 100th percentile. And so our 95th percentile is going to fall in between these, and we would say that the 90th percentile is going to include, or is going to have, a value of 22. 22 right there. So that's our 95th percentile. Now, this is just one way to do this with cumulative percentages. There's a more refined way if you're looking for the value or for a percentile value with a very specific percentile rather than using the cumulative percentages, and I'll show you how to do that in the next video.